Programs run in a straight line, finishing one instruction before moving on to the next. Kinda like taking steps on a path. But if you're following a path, usually you'll run into a fork where you have to decide which way to go. Computers have moments like that too. The difference is that they don't decide on their own. They only follow the rules that we give them. So let's define what I mean when I say a computer makes decisions. What I really mean is that a computer checks a condition and then follows a specific set of instructions depending on the result. And that is why these are usually called conditionals. Now, we are in charge of setting those conditions as well as how they're evaluated. So let's think back to our path again. Now, in the last video, we talked about computers finishing one step after another in order. So that path would look something like this, a straight line from the start to the end. However, if we think about a fork in the road, we have one path that will go one way and one path that will go another. And usually when you come to one of these, there will be a sign that says go this way for Narnia or go that way for Oz. And as long as you know the destination, which in our case, let's say we're going to Narnia, the decision is very easy. So you would start on this path until you reached this fork in the road. And then all you do is ask, does this way lead to Narnia? And if the answer is yes, then you go in that direction. Now, another way to think about this is you check a side path. And let's say you're wanting to go to Oz instead of Narnia. So you start here and you walk down the path and you get to this point here. And you check the sign to see, hey, does this way lead to Oz? And if not, then you just continue down this main path. Now, one thing to note is that you can stack decisions. So if we go back to this example, you come to this fork in the road and you check one sign. Let's say you check the Narnia sign, but you're wanting to go to Oz. So that way does not lead to your destination. But you can go and check the next sign, which in this case does lead to your destination, which is Oz. So you can follow that all the way over to Oz. The main point I'm trying to make is that these decisions that computers make come about by checking something and then acting on the results of what it just checked. All this does is redirect the flow of the program. Even at a decision point, the computer is still following the same rules, one step at a time in order. So it will first check the condition, then it will follow one path, and that path will still be followed step by step. And it's possible that some paths will be skipped altogether, but they still exist for a reason. Sometimes you may want to go to Narnia, and other times you may want to go to Oz. So we get to the question of why does this even matter? Well, without this, all programs would feel a whole lot less smart. If you're playing a video game and you tell an NPC hi and bye, this is what allows it to act accordingly. If there were no decisions, the game would be stuck saying hi at every interaction you had. So now we have two behaviors of a computer. A computer can go in a straight line, and we can redirect it to go a certain way depending on some condition. But what happens when a program needs to follow the same instructions more than once? That is where loops come in. And that's what we'll talk about in the next video. Thanks for watching.